Both questions 6 and 7 have to do with the area of a regular polygon, and the formula for that is 1/2 times the apothem times the perimeter of the shape. The apothem is going to be this line right here. It goes from the center of the shape to the midpoint of the side. So this particular question actually gives us pretty much everything we need. We don't have to find anything. Well, we have to find perimeter, but we don't have to do fancy calculation. I have 1/2 times my apothem of 15, and now again I want perimeter. If one whole side is 18, and there are 5 sides, 18 times 5 gives me a perimeter of 90. So I have 90 times 15 times 1/2, and I get an area of 675 units squared. Okay, next, number 7. It's the area of a regular polygon again. Not only do they tell me that it's regular, but they marked up that all the sides were congruent. So we're going to use that 1/2 times the apothem times the perimeter again. Now, this time they didn't give me the apothem and a side measure like in number 6. They just gave me a side measure, which means I can at least find the perimeter. I have 1, 2, 3, 4, 5, 6, 7, 8 sides. So I have a perimeter of 32. We still need the apothem. And remember, based on what I said on the last question, the apothem goes from the center and it extends to the midpoint of a side. So I can draw an apothem in here. Let's say I make this my apothem. It's perpendicular to the middle of the side. This is what I need to find the measure of. If every side is a total of 4, that means this side was just split into 2 and 2, correct? In addition to that, we can create what's called a central angle. A central angle uses 2 radii. So a radius, while an apothem goes to the middle of the side, a radius goes from the center to a vertex. So if I draw these 2 in, I'm really curious about the angle measure that was just created. Now, if I consider the fact that I could create 8 central angles here, by drawing in all the radii. If I were to consider all of the angles all together, they would make 360 degrees, right? But I don't want 360 degrees. I want to know only what this one angle is worth. So if there were 8 of them, 360 divided by 8 tells me that this is a 45-degree angle. But now what I really want to do is focus in on one of the triangles that were just created. Often what I personally do is I'll draw the triangle out individually so that I don't get confused with other pieces. I know this is a right triangle, right? We already said this bottom is 2. This is the apothem. And if this entire angle is 45, that apothem splits it in half to tell me that this angle is 22.5. At this point, we need to do some trigonometry. From this angle's point of view, I know the side opposite from it, and I want the side adjacent to it. So if you remember SOHCAHTOA, that means you're going to be using tangent of 22.5. That's equal to the opposite side of 2 over the adjacent side, A. At this point, we have to set up our proportion and cross multiply. When I cross multiply in this direction, I have A times tangent of 22.5 is equal to the cross product in this direction, which is just 2. And if my whole goal is to find out what the apothem is, let me divide by tangent of 22.5. What that does is it gets my apothem alone. That's what we're doing here. And I can do 2 divided by tangent of 22.5. And that gives me that the apothem is approximately 4.8284, etc. So when I go and substitute that into my equation, 0.8284. I have 1/2 times that apothem times a perimeter of 32. And when I go ahead and type that into my calculator, I find that I have an area. Oh, I didn't even have to find area in this question. My apologies. We found the apothem. So my apothem is 4.8284, but the area, had we been asking for it, was 77.3. Okay, hope that helped. Bye-bye.